My name is Suresh Andani. I'm a senior director in the AMD Cloud Business Unit, mainly responsible for driving go-to-market strategy and execution for our cloud business. Today marks exactly my third anniversary at AMD, and every single moment of those 3 years, I've been really excited in bringing compute solutions in partnership with Google Cloud to our customer base, all of you guys. I'll spend the next 30 to 35 minutes to walk you through all the GCE and GKE solutions powered by AMD EPYC CPUs in Google Cloud. That would leave us roughly about 5 to 10 minutes in the end for Q&A. And I suggest if you can hold on to your questions till the end, come to the mic and ask your questions. That way, the broader audience will be able to listen to your question and we'll have a more meaningful discussion. With that, what are we waiting for? Let's get started. Before I actually dive into the AMD EPYC-driven GCE and GKE solutions in Google Cloud, let me give you a little bit of overview of AMD as a company. AMD is not only just a server CPU provider anymore. We have established ourselves in the last couple of years as true holistic data center solutions company. Starting to the left, if you see far left, is the AMD EPYC line of server CPUs targeted towards enterprise and commercial HPC workloads, both on-prem and in the cloud. With generative AI, large language models, inference and training being the most talked about, the most sought after workloads, we are very excited with the AMD Instinct line of GPUs. They are really with MI250 in production right now and MI300X coming out in Q4. We are again very excited to really put the solution in front of our end customers, which is again targeting AI, ML, large language models. Last year, we acquired 2 companies. Xilinx, which is the leading provider of programmable FPGA solutions and adaptive SoCs. We acquired Xilinx around the first quarter of last year. And what that did for us is it increased or expanded our TAM from just server data center to like markets such as telco, markets such as embedded, fintech, so on and so forth. We also added Pensando's, which is a programmable P4-based SmartNIC DPU company. And what that did for us is it provided us with a companion SmartNIC, a companion chip, which actually offloads some of the infrastructure workloads such as crypto, storage compression, decompression, networking encryption, decryption. It offloaded the CPU and brought it into the SmartNIC DPU, which is P4 programmable again, and that leaves more codes for end user application. So this basically completed our holistic data center solution kind of strategy, and now we are in execution mode. All right, so in this session, we're gonna mainly focus, out of the 4 solutions I showed in the previous slide, we're gonna mainly focus on the AMD EPYC line of server CPUs. There are lots of benefits, multiple benefits from the AMD EPYC architecture. Starting with TCO. If you look at AMD EPYC, all the way from Naples to Rome to Milan and now to Genoa, it provides the highest x86 core density with the industry-leading performance per core. If you multiply the core density per socket with performance per core, what that gives you is an extremely compelling TCO, which is not only beneficial to our hyperscaler partners like Google Cloud, but a lot of that is passed on to the end customers in terms of either performance per core or in terms of dollar per VM. And that if you are optimizing for cost, that gives you an excellent cost-efficient infrastructure. If you're optimizing for performance, same thing. A lot of enterprises now are also optimizing. the sustainability aspect of it, the social responsibility aspect of it. The enterprises are not only optimizing or reducing their Scope 1 and Scope 2 emissions, they want to really optimize their Scope 3 emissions for workloads that are migrated to cloud. AMD EPYC CPUs with the latest TSMC 5 nanometer technology and the chiplet architecture is the most energy efficient x86 CPU that you'll find out there. So that's again a big advantage from the AMD EPYC architecture. Next is the ecosystem. Lots of enterprises have been running their x86 applications for 10 years, 20 years, 30 years. You really do not want to go touch those applications that have been bringing business to you, that have been interfacing to your customer base, and add risk and effort by porting that to a different architecture. So AMD EPYC, again, based on the x86 architecture and available in all geos within Google Cloud, gives you that ease of migration for your workloads that you were hosting on-prem, but now you can easily do that in the cloud. Last but not the least, confidential compute. Verticals and markets such as healthcare, FSI, public sector, one of the key hesitation in moving the workloads to cloud is, will my workload be secure? Will my application be secure? Will my application, my data in the cloud be secure? So confidential compute in Google Cloud is exclusively powered by AMD EPYC VMs, both confidential VMs and confidential containers within GKE. All right, so now let's really go dive into, I'm going to skip this one, really dive into the different families, compute families we have powered by AMD EPYC in Google Cloud. One size does not fit all anymore. When we started our journey and our partnership with Google Cloud, we only had the general purpose VMs powered by second gen AMD EPYC, codenamed Rome. And since then, we have gone from general purpose, we have added to the portfolio of general purpose N2D VMs, compute optimized C2D VMs, cloud native optimized Tau VMs, T2D VMs, and confidential VMs. So starting with N2D VMs to your left, these are really targeted towards your enterprise lift and shift workloads, such as web and app servers, small to medium-sized databases, line of business applications like media encoding, transcoding. It really provides you a very easy button lift and shift from on-prem to cloud for mainstream enterprise workloads. But as I said, one size does not fit all. When you look at the cloud HPC market, which basically right now, according to Hyperion Research, is about $6 to $7 billion, and it is going to go at a CAGR of about 17% between now and 2026 to about $11 to $12 billion. Your commercial HPC applications, automotive, aerospace R&D designs, computational fluid dynamics, drug discovery, oil and gas and energy exploration, these kind of workloads really require compute-intensive infrastructure with very ultra-fast, high-performing cores, the highest memory bandwidth per core, highest memory capacity per core, and also very fast networking, low latency networking for your tightly coupled workloads. That's where we kind of launched C2D VMs in 2021 in partnership with Google Cloud. Now, right at that time, we also realized that there is a need to really provide a highest priced performance cloud native architecture or VMs, which are targeted towards scale out workloads. And AMD and Google Cloud combined and co-engineered this new family of VMs called Tau VMs, T2D, which was based on third generation AMD EPYC Milan. And these provide up to 42% better price performance and 56% better performance compared to any other VMs available on Google Cloud or elsewhere. And I kind of touched a little bit about confidential compute. Both N2D and C2D families have confidential VM capability and feature support, and also confidential GKEs supported on these two VMs. Okay, let's kind of double click into each of these VM families, starting with N2D. I just mentioned that N2D is really targeted towards your mainstream enterprise workloads. Web serving, think about app serving, Java applications, think about databases, both SQL and NoSQL. Think about just line of business applications like media encoding, transcoding, gaming, so on and so forth. So these general purpose VMs, N2D, we started off with second gen EPYC with Rome in 2020, and they were refreshed with third gen EPYC Milan in 2021. These N2D VMs, general purpose VMs, are the highest VM density or highest VM size you will find in Google Cloud with 224 vCPUs as the highest VM size. They're also 13% lower cost compared to comparable N-series instances available on Google Cloud. So again, think about highest performing VM per core multiplied by 13% lower cost per VM really gives you that TCO advantage that I was talking about earlier. And if you see the charts to the right, what we did is we benchmarked N2D Milan, which is the third generation EPYC, with N2D Rome, and it provides about 30% better price performance for workloads such as Nginx, databases, MySQL, so on and so forth. So now let's talk about a couple of partners and customers who have really leveraged and benefited from migrating to N2D VMs. SAP, which is the leading enterprise business software provider, think ERP, CRM, so on and so forth, they chose N2D VMs as a default for their Rise with SAP program. The main reason why they chose N2D VMs was the price performance benefit and the global availability of these VMs. The other two customers I want to highlight that really benefited and adopted the N2D VMs is Salesforce. We all know about Salesforce here. Salesforce, for similar reasons to SAP, adopted N2D VMs to host its industry-leading enterprise CRM SaaS solution in Google Cloud. Vimeo is a leading content and video provider. It's also a SaaS provider hosting on Google Cloud. They saw 20% lower transcoding time or faster transcoding, video transcoding using N2D VMs compared to the previous infrastructure they were using. They also at the same time saved 20% cost while hosting on N2D VMs on Google Cloud. All right, so we talked a little bit about general purpose N2D VMs. Let's switch over to compute optimized HPC focused C2D VMs. These VMs, again, are targeted towards more technical workloads, which are very compute intensive. Computational fluid dynamics for automotive and aerospace, energy exploration for oil and gas, weather forecasting by national agencies. Those are the workloads that are very compute intensive, network intensive because they are tightly coupled, and also memory bandwidth intensive. So with C2D VMs, it's also the highest VM size as far as compute-intensive workloads or VMs are concerned in Google Cloud. It provides up to 112 vCPUs at the largest size, and you can rent out the entire node to really host in a sole tenancy mode. Just like N2D VMs compared to other N-series VMs, C2D VMs are also offered by Google Cloud at 13% lower cost compared to comparable C-series VMs. It also provides 30% better price performance compared to general purpose N2D VMs, as you could see from the chart to the right. But more interestingly, I want to kind of quote two customers who benefited from migrating to C2D VMs. AirShaper is an online aerodynamic simulation platform company, and they saw 50% reduction in their overall simulation costs and 30% faster simulation times when they migrated to C2D VMs. And Clutch, which is a marketing and data analytics company providing the feature set data analytics, feature set real-time analytics to end enterprises, saw similar benefits of adopting C2D. On this slide, let me sum up all the features that are available on N2D and C2D. Starting with the top left, I mentioned earlier, and we're going to talk a little bit about confidential VMs. Both N2D and C2D offer confidential compute capability and confidential VMs and confidential container capability powered by AMD Secure Encrypted Virtualization SEP technology. We're going to talk about it in just a little bit. They both also support up to 100 gigabit per second networking, very fast networking, which provides enough networking bandwidth per core really required for HPC workloads in C2D and large size enterprise workloads, VM size in N2D. Both also offer local SSDs. N2D offers up to 9 terabytes of local SSDs, and C2D offers up to 3 terabytes of local SSDs for your really IOPS intensive workloads. And finally, both these are available in a sole tenancy configuration. So if you belong to an enterprise which is concerned about security from neighboring VMs or in a multi-tenancy mode, or let's say if you're enterprise which you're mainly running on-prem and you're doing lift and shift to the cloud and bringing your own license, these VMs in a sole tenancy mode allows you more flexibility. It allows you more direct lift and shift to Google Cloud compared to multi-tenancy options. All right. So far we talked about general purpose N2D VMs and compute optimized C2D VMs. Let's kind of double click a little bit about this completely new family that Google and AMD co-engineered, which is the Tau VMs, T2D VMs. These are available from vCPU sizes from 2 all the way to 60 vCPUs. And again, as I mentioned, they were co-engineered really to serve one purpose. A lot of cloud-native, scale-out workloads needed a reason to really go migrate to the cloud, because obviously the cloud architecture provides that scale-out capability. One of the key blockers, if you will, were like, does it provide me the right price performance? So AMD and Google co-engineered this from a performance side to provide the industry best performance. So it provides up to 56% better performance compared to any other VMs in GCP or elsewhere. But to top it off, and another icing on the cake, Google Cloud really priced this very aggressively to give you up to 42% better price performance compared to any other VMs available elsewhere. And you can see some of the charts to the right which shows the price performance comparisons. Oops. Two of the leading social media and collaboration companies, Twitter, now X, is hosting on T2D VMs because of the price performance value prop we provide and the cloud native scale out capability, because these workloads, these applications are very elastic in nature, depending on how much news, how much users are using it. So they needed that kind of flexibility at a good price performance point, which was the main reason that brought Twitter onto T2D. Same with Snapchat. Snap really adopted T2D's technology or T2D VMs exactly for the same reasons. Oops. All right. So let's recap. We talked about general purpose N2D VMs. We talked about compute optimized HPC C2D VMs. We talked about cloud native scale out Tau VMs. One of the features that is exclusively available only on AMD VMs in Google Cloud is confidential compute. What is confidential compute? Historically, if you look at data and the journey of data from on-prem to edge to cloud, data is moving, it's in transit. Data is at rest within the disks and NVMEs. But there's also data in use being processed in the CPUs. For decades, there have been technologies to really encrypt and secure both data at rest and data in motion. Data in motion is secured by IPsec kind of at the network. Data at rest in the disk is secured by all the AES encryption technologies. The hole we had over here was, how do you secure the data in use or being processed? The data in use or being processed, if you think about multi-tenancy VMs running on the same host, you need to make sure that your data in your VM is protected and secured from rogue and malicious VMs, neighboring VMs, and it's also protected from the rogue and malicious hypervisor. And also, the zero trust model says that it needs to be protected by your cloud service provider and the silicon provider like Google Cloud and AMD itself. It's a completely zero trust model. That's where AMD's secure encrypted virtualization SEV technology comes to play. And Google was the first hyperscaler to adopt this SEV technology and launch confidential VMs and confidential containers based on this technology. We can literally spend 1 hour going in depth, but don't worry, I'm not going to do that. Let me net it out of what SEV is. What SEV is it provides, within every AMD EPYC chip, there is a hardware, there's a secure processor which provides a hardware root of trust that encrypts the data, not only in the main memory, but also the data in the CPU registers that is being processed. It manages the hardware encryption keys such that only the hardware knows what those keys are, and your data center operator does not have access to those keys. What that does is provides a zero trust model to secure your federated data or your regulated data. I think the key points over here, without going into the details, because you guys probably are not interested in the sausage making behind this, but the key takeaways from this is two things. One, you can enable SEV and confidential VMs and containers by a push button within the Google Cloud UI. There is no need to touch your application code that you have been running stably for 10 years, 20 years, 30 years to make it secure. Just click a button and your workload, all the hardware encryption, root of trust is enabled and all taken care of by hardware. It provides confidentiality, which means nobody can go and steal your data. It provides secure integrity, which means nobody can go and corrupt your data. And it also provides attestation at a hardware root of trust level. The last and final thing that you should remember is we spend a lot of time benchmarking what is the performance impact if you turn on this SEV confidential compute feature, and it is almost minimal to zero impact on your workload performance. So you are getting a lot of automated security without having to give up too much on your performance or at all. So there are a couple of things I want to mention here, just what's available. Available today with AMD SEV technology that provides your confidentiality, not integrity yet, is in general availability on N2D and C2D VMs, both confidential VMs and containers. And what is in preview, which was announced, is SEV SNP, which actually provides the memory integrity protection. What that means is nobody else, a malicious hypervisor or malicious VM or a data center operator, not only can they not steal your data, they can also not corrupt your data. So that was just announced. It is in public preview and will go in GA very soon. And SEV feature is available on N2D and C2D, whereas the SEV SNP feature in public preview is enabled on N2D right now. All right, more importantly, I want to talk about a couple of customers who belong to a very regulated, federated industry. AstraZeneca, that we all know about, is a healthcare biosciences company who really develops vaccines for many different types of diseases. They store a lot of confidential client data, and it is of utmost importance for them that that information is not leaked out, that information is not corrupted, that information is not stolen. They really leverage the confidential VMs on N2D and C2D to do that. And Icon is another blockchain FSI fintech company, which really leveraged the confidential VMs powered by AMD EPYC SEV technology on Google Cloud as well. All right, so far, just a quick recap. Talked about history, talked about AMD as a company, as a solution provider, talked about general purpose N2D VMs, talked about compute optimized C2D VMs, talked about cloud native T2D VMs, talked a little bit about confidential VMs. This brings us to the exciting news for this week. Google Cloud just announced yesterday their next gen general purpose VMs, C3D VMs, powered by AMD's latest 4th gen EPYC CPUs, codenamed Genoa. So this was announced yesterday. We are very excited about it. Before I get into C3D VMs and what it provides to you as a customer base, let me talk a little bit about Genoa first. Genoa is industry's highest core density, highest performance per core x86 CPU. It packs up to 96 cores of highest performing x86 cores within a single socket. And that's the part that has also gone into the C3D VMs. It also provides up to 2.9 terabytes of memory per node. On top of it, it provides 12 DDR5 memory channels attached to the CPU, provides the highest memory bandwidth per socket and highest memory bandwidth per core. This is very critical for HPC workloads and even some in-memory databases. And then there are 160 PCI 5 lanes, which really drives the highest IOPS available on this platform for your IO-intensive workloads. So I talked about C3D a little bit. This is in preview. This will go into preview very soon. But it's available in various shapes, all the way up to 360 vCPUs with 2.9 terabytes of RAM, as I mentioned, of DDR5 RAM. And it's 4,800 megatransfers per second is the bandwidth or the speed. And again, targeted towards your mainstream general purpose workloads. So the first thing we do when we get this is, before I get there, we also upped the total networking bandwidth on this compared to N2D. It now offers 200 gigabit per second networking bandwidth per node compared to 100 gigabit per second that was there in N2D. So if you add up highest number of cores, highest performance per core, 200 gigabit per second networking, fastest IOPS available, that translates into real-world performance uplifts. And we benchmarked this with the Google Cloud engineering team, and we are seeing 45% better performance on C3D VMs on an average across all the critical workloads like web serving, Nginx, in-memory caching databases like Redis, relational databases like MySQL, and Java workloads as benchmarked by SpecJBB. So 45% average higher performance, which is a huge step function jump generationally compared to the Milan-based N2D VMs. All right, so this is my last slide. It's no good if we have great technology but not available in your geos and regions. So we work constantly and continuously with Google Cloud to really grow the footprint quarter over quarter. So with the exception of C3D, which is just in preview right now, all of our other VMs are available in multiple geos across the world, wherever your enterprises or your data center operations are. And with C3D now announced in preview and going in GA soon, you will see a lot more availability for C3D to a data center near you. Thank you.